Okay, maybe we should make notes in the.
All right, so the general idea here is that a number of operations could be sped up by if we had an index of which objects existed for an RBD image. Things like you could be able to tell how much space is actually being used by the image at a finer granularity. When you're deleting an image, you can only delete the objects that you actually need to delete instead of going through the entire thing. If it's let's say you accidentally created a 1 petabyte image with 0 objects in it. Another big one is for clones. If we had an index of which objects existed in the clone, we wouldn't have to go back and read from the parent as often. Or know under which circumstances we could go and read from the parent directly instead of going to the child first to see whether that object existed and then going to the parent. So it saves an extra round trip request.
So it's actually two things. They can avoid reading objects in the parent that aren't allocated, and they can avoid checking to see if the child.
Yeah, it goes beyond this one level too. Like you could skip directly to say parent number 5 if there's like a chain of clones as well.
Yeah. Okay. Those are the 2 improvement there.
So those are the basic like reasons for ideas for why this would exist. Like differentiate rate, you just put in etherpad as another one. Could speed up the differential snapshot generation to make it an order of the objects that actually exist rather than the size of the image. So in terms of how this is implemented, I guess we've generally been talking about a kind of global index of which objects exist for the entire image, which might be stored as a single object, and some information in the RBD header about whether that index is actually considered to be consistent. So when a client goes to open the image, it can read the header, and if the consistent flag is set, go and read the bitmap and set the flag so that it's no longer considered consistent, and then just keep that bitmap in memory and update it in memory as it's running. And then when it's done with the image, when it closes it, it can save the bitmap and then mark it consistent.
So actually on open you would clear the flag.
Right.
Load it and then clear the flag. Okay.
Yeah, exactly. Some things we have to consider about. Well, actually, first of all, I guess I'll mention also Hamway's idea of the shared flag. The idea is that since the majority of use cases for RBD involve only a single writer to the image, it makes a lot of sense to have this these bitmaps generated by default, and there could be a shared flag on the image header that defaults to false. But and if it's false, then we can use the scheme to generate these bitmaps and keep them consistent with one writer. And if it's actually a shared image that's used by something like OCFS2 or GFS or some other layer on top that uses multiple writers at once, we can avoid using this single writer scheme.
Mm-hmm. There's sort of backward compatibility issue where we want to make sure that old unenlightened clients who open the image basically clear the flag, I guess. Does the existing RBD open the like class operation? Can that capture that? Or is it a read-only operation?
Yeah, so that's a good question. I was thinking it might be like a feature bit for that's set on the image, so that when old clients that open the image would say they aren't able to understand it if they have this
so they would fail.
bitmap feature set. Yeah, so they would just fail.
Okay. And so you would have to do the RBD CLI thing to clear the flag, and then the old clients could then use it again.
Right. So we might want to have like a CLI command to set and unset the flag, and maybe to regenerate the bitmap after the flag is set.
Something like that. Enable, disable, or whatever.
It's about the topic copy and read.
What about copy and read?
No, we're discussing a bitmap here.
Or do copy and read next. Yeah.
Okay.
Sorry.
So one of the issues that comes up with the opening it and having a single client being responsible for the bitmap is that things like snapshots or resizes or other things can happen while there's another client actually using the image. So we might have to have a special flag or a special version of open that doesn't do anything with the bitmap, or it's not strictly read-only, since it's doing things like taking snapshots, but it's not actually doing any data modifications.
So you could have an old RBD CLI version creating a snapshot, basically, even though the feature set.
I wasn't thinking about that so much as just so if we had like two clients that were ignoring each other, and they both opened it and tried to I regenerate the index perhaps, and then they closed at different times with different end states that might not be consistent at the end, right?
All right. Okay. Yeah, I think this would probably need to be used in conjunction with blocking. Right.
Yeah, possibly. Then you also get into like other cases for like live migration where it's open from more than one place at one time, where you want to transfer ownership of the from the source to the destination once the live migration completes.
Isn't the locking system set up to handle that though?
The locking system isn't really set up to handle transfer of ownership.
Well, sort of it is. You list who the old lock holder is, you blacklist them, and then you break the lock, and then you take the lock. I mean, it's a
in particular process. Though, I thought that we had a mechanism where you could like specify it as shareable and provide a tag, and then if anyone else came along and tried to open it with that tag, then they were good to go, or something like that.
Right.
But maybe that was the old version of locking that we replaced, because there was one of them was designed with migration in mind.
It's the same one.
Yeah, so I guess we might be able to do that, but we need some mechanism to communicate that shared tag from the first instance of QEMU to the next one.
Mm-hmm.
I mean, I think we should try and move towards using locking, but if we didn't want to, we could also deal with this by having like an existing tag and an old tag that the clients grab when they open the bitmap, and then set, or then supply and set when they write it out. Although I guess that doesn't prevent one of them from successfully updating inaccurately.
And it seems like the thing that we want to move toward is, the locking is cooperative, but make it like default or, actually used. And so it seems like the ideal situation would be you have one VM that owns the image. It has an exclusive lock, and it does that because, and it's whatever the lock is, and it has the exclusive flag. And if we want to trigger a migration, then you'd send like a notify that says, go into shared mode because I want to share the lock so I can do the migration. And when that message gets sent, there'll be a transition of the client to shared that involves flushing out the bitmap and essentially like disabling, or not flushing it, but just almost marking it inconsistent, or I mean, actually, is there a way to do a multi-client? Probably not. Like, we really just want to validate.
That's the great thing about live migration, right? Is that they're moving the disk state, so they don't actually. So the bitmaps will be consistent. Oh no, because that happens inside of the VM and this is outside of it.
As long as one detaches before the other attaches, or something like that, right?
Right. So that's not. But yeah, it's not actually that simple though. They're still like technically attached and open at the same time. We could maybe do something with like notify, where when it does the source VM does close it, it writes out the bitmap and notifies with a certain message saying that the bitmap's updated, and the destination can then read that and merge it with its in-memory state.
I mean, it's almost like when you like the consistent flag is cleared until the client who owns it writes out the bitmap, and that's it. And so the other guy will think it's not consistent.
How do we handle?
And if he hasn't written anything to it and sees that the consistent flag is suddenly set, then yeah, that seems fragile.
Sorry, can you describe briefly how live migration works with RBD right now? Because it sounds like this is basically the same problem with coordinating caches that you would have already, or at least it covers many of the areas.
So it's different because there's QEMU has a flush operation to clear the data cache and all the pending writes before it opens up the or starts using the VM on the destination.
Okay, so that's just part of it.
Yeah.
Okay.
And there is a separate invalidate call that we could implement in QEMU that could invalidate the bitmap and force the source to flush it out, and then force the destination VM to reread that bitmap. So that might work.
I seem to remember that the locks have like a name associated with them, but they also have a tag, like an extra little bit of information that you can just sort of pass along with the lock.
Yeah.
Like it almost seems like for every client, its sort of relationship with the image involves. You could have a counter of all the writes that it's essentially done. That's that little lock thing. So when I open the image, I have my lock that identifies me as the client, and it says like I've done n writes, or this is my sort of write sequence number. And when you write out the bitmap, you would tag that bitmap and say this is consistent as of write number whatever. And then when another client is looking at it, it can enumerate the locks and say these are the clients that have the image open, and I can see which writes they have or haven't done, and I can see that that client no longer has the image open because they've unlocked it, and the bitmap was consistent as of their. You know what I'm saying? Like if you actually are tracking, you could know that they closed it cleanly. There isn't some other random client that has it open that would have done writes to it. I know what I've done.
Mm-hmm.
Like if you're basically communicating through the locks what writes each individual client is doing, even if they're all shared or something, like even if you're not using it for exclusion, then at least you know who's doing what to the image and you can tell what's valid and what's not. Does that make sense?
Sorry, how do you keep that in sync with the actual writes they're doing?
Well, you sort of, it's not necessarily in sync with the writes, but it's in sync when the client chooses to. It's like the consistent bit or flag or whatever that we originally started with. So when I have a lock open or whatever, when I have the image open and I'm for write, essentially, I declare that the bitmap is inconsistent due to client X, and then I'm doing these writes. So it doesn't matter what write number it is. But then when that individual client closes it, then I say, I can set the consistent bit. I guess the thing is that the consistent bit, in order to be set, is not really something that's owned by any individual client. It's consistent from the perspective of that particular client that might have been scribbling on the image.
Right.
And so in order for the image to actually be consistent, you have to know that all of the clients that were interacting with it all, didn't scribble on it. And in order to know that, you have to see that none of them have it locked or sort of open for write, essentially.
Mm-hmm.
So maybe it's not even maybe it's not a consistent flag. It's just all of the clients, whenever you open it, like they register themselves with a shared lock or exclusive whatever that says that they have it open for write, and it's consistent if none of them have it open for write. No, but it's not that awesome. You
No,
also have to know that when they close it, they
yeah.
And so one way to do it would be to kind of the less optimal way, but the one that would be most correct would be to have the source VM maybe not save the bitmap at the end, and have the destination just recreate the bitmap manually as it's reading the image.
Mm-hmm. Yeah, that's certainly safe.
Yeah.
You could, in principle, you could regenerate the bitmap every time you start up, right?
Right.
Which is maybe not the most efficient thing to do. Or it could just be a cache, right? It doesn't have to be, it can be a partial map of what objects I know don't exist. Actually, we already kind of do that. Like the object cache already has a negative cache.
Yeah, it does.
But that's, yeah.
I guess where it is most it's also useful to store persistently alongside the snapshots, so you can tell like how much space was used at the snapshot between that snapshot and this snapshot and that kind of thing.
Yeah. Well,
What granularity are we thinking about doing this bitmap at? Is it per object or is it on like a block size or?
I think per object is probably.
The reason I ask is if it is just per object, maybe it's feasible. I'm not saying that this is a great idea, but maybe it's feasible to actually make writing to a new object a two-phase commit process where you have to log to the bitmap object that you're going to create the object and then create it and then say this object exists now.
This is originally what we envisioned. Like when we talked about this like 3 years ago, right, in the early days of RBD, and this is originally what we were thinking. Like before you are allowed to touch like when you open the object, you would load the bitmap, and before you could touch a new object, you would have to send an operation to the header that dirtied it.
Mhm.
Yeah.
And that might actually not be terrible overhead, since in most cases the objects will already exist.
Yeah, and I mean generally you're async writing anyway, and
Yeah, it's usually right back. And
so in fact,
I mean,
so
you
in
could
fact,
even
we
have
can,
the
we could do that when it's right back. We're like, oh, we're running to an offset. Tell it that we're
Exactly.
going to write to it, and then later on it's
Right.
flushed.
Exactly. Yep. Yeah. As soon as we get dirty data in the buffer cache, we can update the bitmap. That's probably going to flush that out, and it doesn't have to be precise.
And that would also let us implement a discard in a much nicer way, where you don't have to actually delete all the objects immediately. You can just clear the bitmap for the range.
Well, you need to mark them as need to be deleted or something.
Well, yeah, then the bitmap can say that they need to be deleted, and then you can have that be done asynchronously in the background.
Async. Yeah. That means that the bitmap needs to be it's not a bit, and then it's like a state. It's like clean, dirty.
Which, I mean, if they were
pending,
object
delete,
classes, we could do.
which is fine. Yeah. I think the other thing. Yeah. So before we move on, I think I like this generally better than the consistent flag, because I think the consistent flag just gets dangerous. Like even in the simplest form, if you have a single open close whatever, it could work. But basically, I think probably as soon as you have like live migration or something, you just want to like throw it away and regenerate it or something, because the handoff is going to be complicated.
Yeah.
But even then, I'm wondering if just actually making it properly consistent is not going to be that expensive.
The other benefit of Spring is that it works with shared writers.
Yeah. Yeah. To distinguish between.
However, it's harder to do with older clients.
Yeah. Well, I think that the feature bit would be the same. The same thing. So if you enable the feature for the image, old clients can open it.
Yeah.
And if you disable the feature, then it throws it away. Right.
Maybe.
I don't think this approach wouldn't work for shared writers, right? Because if you have discards as well as creates, then their state could be inconsistent with what they think exists. If they're caching the bitmap.
Oh, well, I mean, sorry, I was. You would also have to do a notify system. But if you're already going to the object, then that's not necessarily infeasible.
Yeah. So in that case, if that was a big use case for shared images, having a shared flag and then maybe only doing a notify when that shared flag is set would make sense.
Yeah. Is there a reasonable way in which we could support older clients where we just are like, crap, we no longer have any idea, and if you want, you can do a rebuild operation? Or should we just...
I think you just disable it for that image.
Okay.
Yeah.
It means that you would have an RBD bitmap rebuild.
Yeah.
Right.
Can we call it something other than bitmap? Because I think if we have multiple states, it's not a bit.
Yeah.
Or dirty map. Or block map. Or just map. Map. X.
So given that though, my question is how we deal with because the object size can obviously vary. So maybe it's a 4 kilobyte object that's got a 4 megabyte space, and it's looking at it for every one of those accesses. Did I phrase that clearly enough?
Can you phrase that again?
So if the dirty map just says this object exists, but it's actually a sparse object, and it's only got 4 kilobytes of data, and the rest of it is a whole that's supposed to fall through to a parent, because we do that, right?
No,
do we no longer do that? We've always
per object.
Okay.
We only
promote an object at a time.
Per object.
Okay.
Yeah.
Okay. So that's actually all right.
So if you had sub-object granularity, you could you could skip the read into the hole, but I'm less worried about that one.
Yeah, no.
Yeah, and
that's
reading
an easy
a
one
part of
to-
a block device that you've never written or doesn't have any data is not a very common thing to actually happen. Like,
Yeah, it's not supposed to happen ever.
Right.
Theory, right?
Yeah. Okay.
Unless you have an insecure file system.
yeah.
Yep. Okay, so can we? I think this is more. Okay, so let me capture the other ideas. Can preemptively dirty an object a bit, for lack of a better term, when dirty data hits the object cacher. So that would avoid it in the right path when caching is enabled, which is sort of the case that we mostly care about.
Mm-hmm.
What about snapshots? What happens to this when we take a snapshot? Do we just make a copy? At the time the snapshot happens, we just
it's kind of
copy
tricky
in the header.
Yeah, I think so. Let's see. I forget whether we flush everything out immediately when we take a snapshot or not. I think we do. But if we do, then we can actually include that as well.
Because the snapshots usually can be triggered by another client. So you send a notify. I mean, you basically register the snapshot in the header to say that it logically exists. And then you tell the clients to start using the different snap context.
Do they use that snap context on the header already?
It basically just makes them refresh the header. That's all. But I think at that point the bitmap isn't going to be quite coherent because they might have writes in progress before they see the snap context, right?
Yeah. So when we do get a snapshot, we actually do flush the cache immediately, which means that we could actually just use the same snapshot context to take snapshots of the index as well, I think.
The first notify won't trigger it?
Sorry?
The initial notify, we've created a snapshot. Won't that count as a write to the snapshot or to the header object?
Yeah, it does, but that doesn't actually matter.
I think there's an ordering problem though.
Yeah, that's my concern. Because if you're going to say notify with the new snap context, then it's going to create a copy of the header object, and that's going to be the wrong version of the bitmap. If the other RBD users still need to flush out the bits.
Well, I think you just make the initial notify and not use that snapshot context. Just use the
no, yeah, Josh is right. Josh is right, because the dirting operation is going to go to the header or the object that has the bitmap with the old snap context, and so it can
Well, I mean, I think it's possible to do this. I'm asking how much refactoring needs to be done to make sure that's what happens. I'm not familiar enough with the RBD client code to talk about that coherently.
Yeah, I think it would be like the operation
But right now, I think notifies don't actually get sent any snapshot context with them at all, since we don't snapshot the header.
Mm-hmm.
So
which I think
too hard to.
I think the operation that actually dirties the object or dirties the bit or whatever in the bitmap object, if one of the arguments effectively for that operation is the current snap context,
right,
and it's a class operation, then that class can handle sort of saying, oh, that's dirtying prior to the snapshot, and so I'm going to make sure I dirty it both in the before and after versions or whatever, that it's like it could sort of do the versioning of the bitmap inside the class based on even regardless of what order they arrived in. Does that make sense?
Yeah, actually, I guess we could do that. Make the snapshot. So you're suggesting make the snapshot context actually not part of the radio snap operation there, but actually just an argument to the
Exactly.
class. Yeah, that makes a lot of sense,
right.
actually.
Because then you can apply it both to the snap bitmap and to the heads bitmap. I think that's simple for the dirtying case. For the other states, like marking it pending delete or deleted, you'd have to take the conservative path and say, because whatever, you have to like work through those particular combinations and races.
So you want to re-implement snapshots inside of that mechanism rather than using the Rados snapshot?
I think you have to, because they're not necessarily ordered, and it's really simple, right? It's you have like two operations, one that's marking a field dirty, and one that's marking it pending delete, and then one that's saying it was deleted, assuming you actually do handle the discard term stuff, which would be a secondary step. Presumably, but just think of the dirty one. You would just dirty both versions of it. I think that would work.
It's not that it seems particularly hard, as it just seems foolish not to use the snapshotting implementation we already have.
It does, but the snapshot implementation, once you snap the object, you can't modify it.
Yeah, so I mean, can't we just get there by being careful with our snap context ordering?
Okay, so the other path would be to go to doing a two-phase snapshot creation, where you say, I plan to create the snapshot in the header. You send the notify to everyone, and they say, yes, I understand, I'm going to do the snapshot, and then you sort of commit that change. And so you're having a sort of coordinated snapshot creation. You get positive confirmation that all clients with the image open actually did switch to using the new snap context and behave accordingly. And so I think in that case, then I think that would work. I think, Josh, you probably thought more about how the snapshots needed to be fixed than the rest.
Yeah, I mean, that's kind of something that we wanted to do anyway to make it safer in general.
Right. Yeah.
I think the backwards compatibility may be kind of irritating, but I guess if we just started doing that for this, when we had this flag set, then that'd be fine.
Yeah.
And I mean, the main thing is that we have to change everything that goes and modifies the header to actually send the snapshot context, which currently it doesn't.
Well, it's not the header that gets snapshotted. It's
the bitmap object.
The bitmap.
Right, yeah. Right. So that's as long as it's a separate object, then
we just use the other. We just use the data context instead of the header context, the M context.
Right.
Wait, why do you want it to be a separate object from the header?
So that we don't have to worry about writes to the header creating.
All right.
Using the wrong snapshot context, basically.
All right.
Yeah. I think that's simpler. Although I guess it means that you can't do operations on the header that are atomic with other things that manipulate the image at the same time.
Just keep in mind we are coming to the end of this time slot here.
Yeah.
Fact we've run over.
Yep. Well, let's ponder this. So I'll just make notes that we have.
All right.
Options. I'll make some notes here so we don't forget.
Okay.
Yeah. I'm sure we'll think of more little details that cause problems later too.
All right, let me get slipped over here.